Okay, so let's look at how we do this one. We're going to need to do some ray tracing. So first of all, let's consider the ray which is traveling from the top of the object and parallel to the principal axis. This ray, once it hits the lens, gets diverged away from the principal axis. So it travels up that way, but we're going to need to trace it backwards. Okay, now another ray that we're going to want to trace is from the top of the object and then through the center of our lens. And this ray will just keep on traveling in the straight line. Now, actually, we do only need to trace two rays to see where the image is. We can see where these backwards traced rays cross, and so that's where the image will be. But let's just for practice draw our third one as well. Our third ray goes through the focus on the other side of the lens. But when it gets to the lens, it then travels parallel to the principal axis. So at this point here, it's traveling parallel. And so it actually travels this way. And if we trace it backwards, it goes through this same point as well. So we can see that our image is going to be formed here. So let's answer those questions. A, where is the image formed? Well, if you printed it, you could actually measure this distance here. But everybody will agree that it is behind the lens, but in front of the object. And then part B asked us if it was real or virtual. Well, the light rays actually pass this way, and so they're not actually passing through this point here, which makes it a virtual image. And now part C asks us for the magnification, which is equal to the image height over the object height. So what we need to do is get a ruler and measure this image height and measure the object height. Now, when I did that on my printed version of this, I got that my image had a height of 9.55 millimeters. My object height was around about 15 millimeters. Again, yours will probably be a bit different. But overall, this should give you a magnification of around about 0.63.